My dear friend, today in this video we are going to discuss a very important law called Faraday's law of electromagnetic induction. The formula given by our great British scientist Faraday, who gave the formula and brought a revolutionary change in the field of electrical engineering. The two formula, first is this: Faraday's first law is related with how the EMF is induced in a coil or conductor kept in magnetic field. So for first law explain about the relative motion between the magnetic field and the coil or conductor. If there is no relative motion, no EMF will be induced in the conductor. And second law says that the magnitude of the induced EMF is proportional to the rate of change of flux linkage. Rate of change of flux linkage. So first law, how it is produced, and second law, how much it is produced. So these two laws explain the best relation between the electricity and magnetic. How electricity helps to produce magnetic field and how magnetic field helps to produce electricity, vice versa. The relation best explained by the Faraday's law of electromagnetic induction. Now, there are two types of induced EMF. First is statically induced EMF and second is dynamically induced EMF. Statically induced EMF is that EMF which is induced in the conductor when the conductor is in rest. Conductor is not in motion. Only the flux linkage is changing. Only the flux linkage is changing, but conductor is not in motion. In that case, the induced EMF is called the statically induced EMF, and the formula of a statically induced EMF is minus n d phi by dt, where n is the number of turns of the coil and d phi by dt is the rate of change of flux linkage. Now the dynamically induced EMF. Dynamically induced EMF is that EMF which is induced in the conductor while the conductor is in motion. There is a speed of the conductor. So the rate of change of flux linkage is due to the motion of the conductor. So this is called dynamically induced EMF or a speed EMF. The formula of the dynamically induced EMF is that E BLB sin theta, where B is the flux density in Weber per meter square or in Tesla. This is the field strength. L is the length of conductor or coil in the magnetic field. V sin theta, it is the component of the velocity perpendicular to the direction of the flux. Perpendicular to the direction of the flux. So BLB sin theta volt is one of the dynamically induced EMF. The next formula is phi z n p by 16 to A. In a generator, the phi is the flux per pole in Weber, Z is the total number of conductor on armature, N is the RPM, speed of the conductor, P is the number of poles in the generator, and A is the number of parallel paths on the armature. Now 60 here is for conversion of the RPM into RPS, revolution per second. So 60 it is divided. The last formula, Em sin omega t. When the AC is generated by generator, the sine wave, AC sine wave is represented by Em sin omega t, where Em is the maximum EMF induced in the conductor at the angle of 90 degree and again 270 degree. One is plus, another is minus. Omega is the angular velocity of the conductor. So Em sin omega t, it is for the sine wave generated AC, by the generator. So these are the three formula for dynamically induced EMF. Now the question is, how much EMF will be induced in the conductor? This depends upon the three factors. First is the strength of the magnetic field, strength of the magnetic field, flux per Weber. Second is the total number of turns of the conductor or number of the conductor, and third one is the speed of the coil or conductor. So if any one of the three factors is increases, then induced EMF also increases. If any one of the three decreases, then the magnitude of the induced EMF also decreases. So this is related with the magnitude of the induced EMF. Now, the first formula, statically induced EMF, led to the formation of the transformer, a most usable equipment, electrical equipment, that is called statical equipment. There is no moving part in the transformer, and the statically induced EMF led to the development and formation of transformer. The dynamically induced EMF, the formula, led to the development of alternators, generators, and all kinds of motors. Though almost all the machines of the electrical machines are directly or indirectly related with the Faraday's laws of electromagnetic induction, which proved to be a boon in the electrical field of electrical engineering. So we must have the good concept of Faraday's first law and Faraday's second law. First law says how it is produced. Relative motion between the coil and the field is essential. Second law says the magnitude of the EMF is directly proportional to the rate of change of flux linkage dφ by dt, and the magnitude of induced EMF in the conductor depends upon the magnetic field strength, number of turns of the coil or number of conductor, and speed, that is RPM of the armature. If any one increases, then EMF increases. If any one decreases, then EMF decreases. So this is all about the Faraday's laws of electromagnetic induction. Best explain the relation between the electricity and magnet. Thank you very much.